Hi, this instructional video is about graphing log functions. More specifically, this particular instructional video is about what numbers to choose. What numbers to choose to use for input to graph these functions. So, to get things started, first let's look at the general form of a log function and its components. Written in a function of x, let's say y is equal to log base b of x minus dh plus the k. Here's the general form. And here's how the components are described. Since we can only take the positive number for logs, the base b, can only be either greater than 1. And if that happens, the graph, when you graph it, it will go up and to the right. It will always go up and right. And if that base b happens to be a quotient, like less than a 1, but greater than a 0, then it will go down and to the right in a curved format. The x is equal to h, that x is equal to h happens to be the asymptote. And so the domain and the range of the function is going to be numbers greater than h, that's going to be the domain, and all real number will be the range. And finally, the last number constant, k, that's going to tell you whether it's going to shift up or down, the number of units depending on the integer. So that's the general form. So let's look at number 1 and see how this is used to describe. First, the base b is 8 and it's greater than 1, so we know it's going to go curving up and right. Now there is no parentheses on this one, so in fact it's just x minus 0. So the asymptote is going to be 0 and domain is going to be x is greater than 0 and range will be all real number. And what's that constant k? That's that minus 2. So it means the entire graph will shift 2 units down. So let's go ahead and see how this works. The way I recommend you do it is write this in exponential form using just log base 8 of x. And whatever you get, minus 2. Here's what I mean. Take a look at this. Write that in exponent form, you get 8 raised to what number is x. And this is where you want to start choosing the domain for input to graph. So you go, here's my x and y, table of values. Using the 8 as a base, raised to what number would you prefer this to be? Well, I could always make that into a 1. So you ask yourself, 8 raised to what number gives you a 1? Well, the exponent has to be a 0. Now that 0 minus the 2 constant gives you the y value. In this case, it's going to be negative 2. Did you see that? What's another logical number you want to choose for x in this exponential form? Did you say 8? I would. So 8 raised to what number will give you 8? It'll be 1. Minus that constant 2 is going to be negative 1. How about 1 over 8? How would this base 8 become 1 over 8? If that exponent is negative 1. And that negative 1 combined with this constant negative 2 gives you negative 3. Now we're ready to graph. So here's my coordinate plane. If x is 1, y is negative 2. There it is. If x is 8, let's just approximate and say over here, this is 8, okay? Then y is negative 1. And if x is 1, 8, then y is negative 3. Way over here. And that seems to coincide with the fact that since the asymptote is at 0, right there along the y-axis, the graph will look something like this. If you did not have the minus 2 over here, then this will be 0, this will be 1, and this will be negative 1. So in fact, it would have been this way. 1, positive 1, and negative 1. And so it would have looked something like this instead. Because 1/8 is over here, I mean. Okay? So it did shift 2 units down. Alright, why don't you try this one then? Okay, you said the base B is greater than 1. So it's going to go up. Just like this one. It goes up to the right. The H value is 0. So that's the asymptote right along the y-axis. Just like this one. And it's going to shift upward 1. So now let's write this, just this portion right here, in exponential form. So base 3 raised to what number would give you x? And whatever you determine, you're going to add 1 to it to get the y value. So the first logical number you want to choose is 1, because how does a base 3 become a 1? By making exponent 0. And that 0 plus the 1 is 1. Then the next number is of course 3, because 3 base raised to 1 is 3. But you take that exponent 1 and add it to the constant 1, and the y becomes 2. Did you choose 1/3? Smart! Because how does 3 base become 1/3? If the exponent is negative 1. And negative 1 combined with the positive 1 constant becomes a 0. We're ready to graph. X is 1, y is 1. X is 3, y is 2. X is 1/3, and y is 0. Again, since the asymptote is that x is equal to 0, it's going to go along the y-axis, where the domain is x is greater than 0, and the range is all real numbers.